Hi everyone, so this is the first video for the first lesson of the discrete random variables and binomial distribution pack. It says 5 lessons in total, so we'll see how we do with that, because we might rush the start so we've got more time to work on the binomial stuff. Right, so let's have a look at the first bit. So lesson 1. Right. So we'll see how we do with this as to whether we put lesson 1 and lesson 2 together. Right, so it says, so discrete random variables are something that you can count, as opposed to something you can measure, because that's your main difference, isn't it, between discrete and continuous. So we can count stuff. So we can count it. So it says X represents the score on a single die. So we can count the score, count the dots, can't we? So we know that if it's a fair die, then the probability is a sixth for either a 1 or a 2 or a 3 or a 4 or 5 or 6. So that there is a table showing the discrete random variables for it. So it's just a table showing probabilities. That's all we're saying. There we are. So just a table showing probabilities. So then it says X represents the sum of the scores when 2 die are thrown. So we normally do this in a table first before we get to there, like you'll have done it at school where you have like 1, 2, 3, all the way to 6, 1, 2, 3, all the way to 6. You're adding them together, so if you've got a 1 and a 1, gives you a total as a 2. A 1 and a 2 gives you a total of 3, and that's a 3. So if you look, that there is because there is only 1 2 that appears in the table. And this one here is because there are 2 3s that appear in the table. And because it's a 6 by 6 kind of good box, it's out of 36. So you've seen that before, but you probably not just put it in the table. There. So it says X's are random variables, certain values, something counting really. Discrete, that we're kind of counting, and the probability distribution tells you the values of it. So it says, if 2 identical fair tetrahedral dice are thrown, each with faces numbered 1 to 4, and it wants the sum of the scores. Okay? So if I add them together, I get a 2, a 3, a 4, a 5, a 3, a 4, a 5, a 6, a 4, 5, 6, 7, and a 5, 6, 7, 8. There. Now I'm going to do sort of probability distribution, sort of the table that goes with it. So, if you look at the values I've got in here, I've got 2, 3, 4, 5, 6, 7, 8. So them are the ones that I've got. Them are my outcomes for it. So I've got the probability that X is equal to X. So 2 is the first value, then I've got 3, then I've got 4, then I've got 5, then I've got 6, then I've got 7, then I've got 8. So these are all the outcomes in the table. I've got 1, 2, so that's going to be 1 out of, and I've got 16 numbers in the table. Then for the 3, I've got 2 of them out of 16. For the 4, I've got 3 of them out of 16. For the 5, I've got 4 of them out of 16. For the 6, there are 3 of them. For the 7, there are 2 of them. And for the 8, there are 1 of them. Oops. Now, if you add them up, all these, you've got 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 3 is 13, plus 2 is 15, plus 1 is 16, so that's 16 out of 16. So the total is 1, and you'd expect that. So how we can write it is the sum of the probability that X is equal to X is equal to 1. And that's important for the next lesson now. So the sum of the probabilities is 1. So that's that bit done. So then it says, for example, 2, it says a single dice is rolled once and the score is noted. If the score is a 1, 2, 3, 4 or 5, the score is doubled and this is the final score. Right, okay. So the score is doubled. So instead of a 1, 2, 3, 4, 5, I'm doubling the score. So I've got a 2, a 4, a 6, and an 8. Oh, hang on. So I think that's wrong. So I'm going to... right, hang on. I've misread this. I'm just going to go back and think about this if you read it. So it says the score is a 1, 2, 3, 4, 5 is double. So if on the first dice, so if the first dice is rolled, I can get a 2, a 4, a 6, an 8, a 10, or a 12. There. But if the first dice is a 6, so this is like the first dice being a 1 to 5, so I'll get that 12 on there. So if it's a 1 to 5, we double it. If it's a 6, we then chuck it again and add it on. So if I get a 6, then I can have a 7, a 6 plus a 1, an 8, a 9, a 10, 11, or 12. So then are all the outcomes that I've got. So just kind of get it right in your head. So if it's a 1 to 5, we double it, so that's a 2, 4, 6, 8, 10. But then if it's a 6, we add the initial score to it. So we add the score of, if we roll it again, so we have a 6 with a 1, a 6 with a 2, a 6 with a 3, etc. So I'll put these numbers in order. So I've got 2, 4, 6, I've got 7, 8, 9, 10, 11, and 12, putting them in the order. Right, now then, let's have a think about getting a 2. The only way to get a 2 is just by throwing a 2, which gives us a probability of 1. We're probably throwing a 1, which is a probability of 6. The only way to get a 4 is if we throw a 2, so that's got a probability of a 6. The only way of getting a 6 is if we throw a 3, and that will give us a probability of a 6. The only let's think about this then. For the 7, the only way to get a 7 is a 6 and a 1. So for the probability that x equals a 7, it would have to be the probability of getting a 6, which is 1 over 6, times by the probability of getting a 1, which is 1 over 6. So that would be 1 over 36. Now it says, show that 8 is 7 over 36. So think about the probability of getting an 8. An 8 can be the probability of getting a 4, or, so add, the probability of getting a 6, and the probability of then, and the 2. So to get an 8, you can either do it from getting a 4, which would be 1/6, or a 6, and a 2 there. So if you put that in your calculator, that does give you the 7 over 36. There. You kind of get that. So to get the 8, is either get a 4 on the first one and you double it, or it's get a 6 and then a 2. So that's where the 7 over 36 comes from. Then if I want a 9, the only way to get a 9 would be to have a 6 and then a 3. So that would be 1/6 for the 6, 1/6 for the 3. So that's going to be 1 over 36. There. For the 10, it's going to be getting a probability of getting a 5, which gets doubled, or the probability of a 6 and a 4. So that would be the same as the probability that x equals 8. It's the same maths that's in there. So that would be 7 over 36. For the 11, the only way to get an 11 is to be a 6 and a 5. So that follows the same maths as a 9. So that would be a 1 out of 36. And then this one's a 1 out of 36 as well. It's a 6 and a 6. I hope that